Hi everyone, hope you are doing great. Welcome back to another video in our manual testing series. In this session, we will understand orthogonal array testing, a systematic and statistical based test design technique that helps to optimize test coverage with minimal test cases, especially for systems with multiple input parameters and combinations. For example, imagine you are testing an online college application form where a student selects the course which has got three parameters called engineering, arts and science. College type has two parameters, government or private. Study mode, it is full time or a part time. If you try to test all possible combination, then you would have 3 multiplied by 2 multiplied by 2, that is total 12 test cases. However, using an orthogonal array technique, you can reduce these to just few representative test cases. That will ensure every possible pair of options. Example, the course with the college type or the course with the study mode and the college type with the study mode is covered at least once. This way you achieve balanced coverage without testing every single combination, saving both time and effort. In today's session, we will cover what orthogonal array testing is all about, why it is used, how to apply orthogonal array testing using real examples, some of the key concepts used in orthogonal array techniques like factors, levels and pairwise coverages. Step 2, design an efficient test cases with minimal combinations using OAT, that is orthogonal array testing. Advantages and limitations of using orthogonal array testing in real world. Orthogonal array testing is a black box testing technique derived from a design of experiment principles. It is originally developed by Dr. Taguchi. It helps tester efficiently identify the defect caused by the interactions among the multiple input parameters while reducing the total number of test cases. So this testing technique is very efficient for the application that has multiple input parameters. So instead of testing every possible combination of input parameters, orthogonal array testing technique uses a mathematical matrix called as an orthogonal array, which is used to select a small representative set of test cases that ensures balanced coverage of all the parameter interactions, typically at the pairwise level. If you are testing a mobile application login feature with the following parameters, that is the browser as a Chrome, Safari and Edge, operating system as Windows, Mac OS and Android, connection type can be Wi-Fi, mobile data and Ethernet, authentication mechanism is maybe using the user ID and password or a fingerprint or the face ID. So in these cases, if you want to test all the combinations, then you will have to test 3 to the power of 4. That is, we have the 4 parameters 1, 2, 3, 4 and each of them are with the 3 combinations. Okay, here it is 3 combination, here it is 3 combination, here it is 3 combination and here it is 3 combination. So it will have the number of combinations to the power of number of parameters. That is, totally in order to test each and every combination you will have to have 81 test cases, which is extremely time consuming and inefficient. This is where orthogonal array testing plays an important role by reducing the number of test cases without compromising any quality. Now let us try to understand why someone has to use orthogonal array testing and what are the challenges basically it solves. The first item is too many combinations to test. If you have an application with multiple input parameters and each of these input parameters has multiple combinations. In such cases, testing all the possible combinations can be overwhelming. What OAT does? OAT chooses only the combination needed to cover all the interactions efficiently. Time and cost constraints. We know that orthogonal array technique is going to reduce the number of test cases significantly. The fewer test cases means less time and fewer resources spent. All these things are done without sacrificing the quality and the test coverage. Lack of prioritization. Orthogonal array technique is basically focuses on significant parameters enabling the efficient and targeted testing. Third point is missing interaction coverage. OAT ensures that every pair of parameter values are tested at least once. OAT guarantees that the interaction between the two parameters, which is called as pairwise, are included, which helps to uncover the defects caused by these interactions. It ensures that instead of testing everything blindly, it emphasizes the parameters that have most impact on the system, making testing smarter. Some of the key terminologies used in orthogonal array testing. The first one is a factor. The factor is also called as an parameter. It is an input parameter or the variable under test. So in our example on mobile application login, the browser is a parameter which can have the different values like Chrome, Firefox or Edge, right? The factor represents anything in the system that can vary and affect the outcome. For example, as I told, browser, OS, authentication, etc. Second one is a level. The possible values that a factor can have. For example, in case of an operating system which is a parameter, we had a values like Windows, Mac OS or the Linux OS, right? So each factor can have the multiple values. As I told, as I gave an example of operating system, we can also take an example of a browser. Browser can have a value like Chrome, Firefox, Edge or the Safari. Orthogonal array, which is an predefined matrix showing the factor to the level combination that ensures balanced test coverage. Okay, orthogonal array is the predefined or the ready-made matrix that is available, that are basically designed by some of the scientists, which helps to select a subset of combination that provides statistically balanced coverage of factors interaction without testing all the possibilities. Whenever someone says that an orthogonal array, it is a matrix, okay, that is designed or that is already designed, okay, it is already available, which basically depends on the factors and the levels. Strength, meaning the number of factors whose combinations are already covered. Strength determines the interaction coverage. Okay. Strength is always denoted by a variable t. Okay. The t can have the different values. T can be 2 or t can be 3. Okay. Higher the value of t, it increases the coverage but requires the more test cases. Okay. For example, t equal to 2 means all the pairwise combinations are included. That means if a browser and if you take the two parameters, which is browser and OS, and browser has a value called Chrome, Firefox and Edge, whereas OS has Windows, Mac OS and Android. The combination of Chrome with the Windows, the Firefox with the Mac and the Edge with Android. All these combinations are basically covered. Okay, that is the value equal to 2. If the value equals to 3, that means all the three-way combinations are included. Okay, the Chrome to Windows, the Chrome to Mac, Chrome to Android, similarly Firefox to Windows, Firefox to Mac, and Firefox to Android. It covers all the combination. So higher the strength increases the coverage, but it also meanwhile it also requires a lot of test cases to test. So test case, anyhow, you know what is a test case. It is a row in an orthogonal array. Each row represents unique combination of factors and levels to be executed in the testing. Exhaustive testing is a testing every possible combinations. For example, if you have 4 parameters and each parameter has got 3 values, then you will have to test all the combination, that is 3 to the power of 4, which is equivalent to 81 test cases, right? That is called as an exhaustive testing. Okay, whereas pairwise testing all the possible pairs of factors and levels. Okay, so it ensures that you are testing all the pairs, right? All the pairs of your parameters. That is, it can be a browser with OS, the browser with connections, browser with authentication. That is what we call it as a pairwise testing. Orthogonal array testing often achieves pairwise coverage efficiently, and this helps to catching the most defects caused by the interactions. Let's take the same mobile banking application and let's apply the orthogonal array testing technique here. This mobile banking application has 4 parameters and each parameter has the 3 possible values or levels. So in total, if you want to test all the combination, then you will have 81 different combination and you need 81 test cases to test. By applying an orthogonal array technique, let us see how many test cases we need to cover all the combinations. This page provides a step-by-step guide on how to apply the orthogonal array technique to a real-world problem. The first step is to identify all the input parameters. Okay, you need to list down all the input parameters that affects the test outcome. Then you need to determine the levels for each of these parameters. For each parameter, define the possible values or states. For example, in our case, for the operating system, we have selected the Windows, Mac OS and Android as an possible values. Then the third step is to select an appropriate orthogonal array. There is a ready-made orthogonal array that is available, which is solely depend upon the number of input parameters and the levels. Okay, so you'll have to select an appropriate orthogonal array like L4, L8, L9 or L16, etc., which is chosen based on the number of factors and levels. So you have this table here. If there are 3 parameters and each parameter has 2 levels, then you will have to go for an L4 array. If there are 7 factors and each of them has 2 values, and then you will have to go for an L8 array. So in our case, we have the 4 parameters, right? We have 4 parameters. What are they? We have operating system, we have a browser, we have an authentication method, and we have an connection type. And each of them has the 3 values. So in our case, we will have to select L9 as an orthogonal array for deriving the test cases. Okay, so this you can also get it in an internet. You can search for the orthogonal array for a specified number of factors and levels. Once you have that, then you will have to take the template of these arrays. In our case, I have to take L9 template, and then I have to start filling that template with the parameters and the levels. And after that, design the test cases, translate the array into the actual test scenarios, and the final step is to execute these test cases. Okay, with the mobile banking application, let us try to apply the orthogonal array technique. Now let us try to apply the orthogonal array technique to our mobile banking application. So our banking application has 4 parameters and each of them has the 3 levels or 3 possible values. Okay. So for these factors and for these levels, the recommended the array for us is an L9. This is the L9 template. With the L9 template, you can derive the 9 test cases. Here the column represents the factors. Since we have the 4 factors, we have 4 columns. Within the column, you can also see the values here, right? This represents the values that is given to each of these parameters. The value 1 here means Android. The value 2 here means iOS. Value 3 means the Windows. Similarly, for the factor 2, the value 1 means Chrome, value 2 means Safari, and value 3 means Edge. And similarly for connection type and authentication. Now let us try to fill this template. So if you see here, the template is filled with the actual values, right? The factor 1 means OS, factor 2 means browser, factor 3 means connection, and factor 4 is an authentication. And within the factor 1, the 1 is Android, 2 is iOS, and 3 is Windows. Similarly, for the factor 2, the 1 is Chrome, 2 is Safari, and 3 is Edge. For the connection, 1 is Wi-Fi, 2 is mobile data, and 3 is Ethernet. For the 4, the 1 is username with password, second one is a fingerprint, and 3 is the Face ID. Now the final step is to derive the test cases. Here we removed all the numbers and substituted with the actual values. Okay. In the test case 1, I will be using a Chrome browser on Windows operating system with Wi-Fi as a connection and authentication as an username and password. For the test case 2, still I am using Chrome as a browser but on a Mac OS with mobile data and fingerprint as an authentication, and so on, right? So if you really don't use an orthogonal array technique, then you would have end up in testing all the 81 combination. With the orthogonal array, we have the 9 test cases to give the complete coverage without any compromise in the quality. So the number of test cases are significantly reduced from 81 to 9. You can also use an online tools to derive the test cases using an orthogonal array technique. I have noted down some of them. I will also put them in the description section of my video. Now let us talk about the advantages and disadvantages of orthogonal array technique. This technique is very efficient when you have the application with the multiple parameters and each parameter has the different values. So it gives an efficient coverage. It comes up with all the pairwise interactions. So it reduces the test cases, fewer test cases than exhaustive testing. Statistically, it can be reliable, identifies the interaction based on the defects, scalable for both functional and non-functional testing. On the other hand, the limitation of orthogonal array technique does not cover the higher order interactions. It covers only the lower order interactions. That means it covers the interaction between the pairs. It assumes equal importance to all the factors. So that is why there are no the prioritization in the testing, right? So it thinks all the parameters are equally important. So it is not ideal for dependent parameters. Now you know the advantage and disadvantages of orthogonal array testings. It is the right time to see when to apply an orthogonal array testing. So orthogonal array techniques are very effective if your application has got multiple input parameters and each parameter has different combinations. So it is mainly used to reduce the exhaustive testing. So it can be used whenever there is an exhaustive testing and all the combinations are impractical to test. Or if you want maximum coverage with minimal effort, then you can use an orthogonal array testing. Or when you are performing a configuration or the compatibility the testing. So you want to test with the different kind of input configurations, then you can use the orthogonal array testing very effectively. That brings us to the end of this session. I hope you enjoyed learning with me. If you find this video helpful, please like and subscribe to my channel. Thank you for watching.